Chemical engineering is defined as an engineering discipline that involves designing processes to transport, transform, and produce materials. Chemical engineers have knowledge of physics, chemistry, biology, and math to design these processes. Now, chemical engineers have a wide range of careers they can go into, which is definitely a perk of this major and what I want to talk about first. So for one, you can go into biotechnology and the pharmaceutical industry, where you design facilities that use enzymes and microorganisms to create new drugs. Companies like Pfizer or Merck are examples of this. You could go into environmental engineering applications, in which they try to reduce the volume of pollutants that enter the air, waterways, and soil. Think of catalytic converters on our cars, which need to be designed to minimize the amount of harmful material that is released. Catalytic converters are essentially just small chemical reactors that aim to reduce the amount of harmful substances released by the car. You could also go into semiconductors and electronics, which is actually very big for chemical engineers that lots of people don't realize. Think about companies like IBM and Intel that design and manufacture microchips and other computer parts. You'd think these places would mainly hire electrical or computer engineers, but these places are huge on hiring chemical engineers. To manufacture these microchips, they start with large silicon crystals that are then cut into wafers. Then the transistor architecture is pressed onto this material. The transistor design is left for the electrical or maybe computer engineers, but the framework or foundation and the process that makes it happen is what the chemical engineers do. Overall, there's a lot of chemical design and chemical processes involved in making those chips. You could work on industrial chemicals like detergents, soaps, and cosmetics, like at Procter & Gamble or Johnson & Johnson. Most people don't realize just how much work goes into that one bottle of detergent you get from the store. You could work on food production like at Nestle or Kraft, or wine and other alcoholic beverages like at Budweiser. You could work in petroleum engineering like at an oil refinery that turns crude oil from the earth into gasoline, diesel fuel, heating oil, etc. You could work for companies like Shell or Exxon, which hire a lot of chemical engineers. So while a petroleum engineer may specialize in designing the equipment to extract the crude oil from the earth, chemical engineers may focus more on designing the equipment that implements the chemical reactions which turn the crude oil into something useful like gasoline or diesel oil, as you can see in this picture, which would be found at the refinery shown above. You could work in alternative energy. For example, there's solar cells, which involve chemical processes to be designed like the microchips I talked about earlier. Or you could work on fuel cells, which convert chemical energy from a fuel into electrical energy. These can be seen in cars, planes, boats, submarines, and more, and you learn how these work and how they are made. And there's even more careers you could get into, but now let's talk about specifically what the chemical engineer does in these fields. Like I said, they make food or alcohol, but how? What exactly do they do? Well, chemical engineers focus mainly on scale-up. This is a term you'll hear a lot if you've done research, as in taking a small reaction and scaling it to happen on a larger scale. This is important and is a main difference between chemical engineers and chemists, which I will get into later. So maybe a new liquid soap is designed in a lab. That's the small scale, just using typical equipment. So now you have the formula for this new soap, but how are you going to produce large amounts of it in huge reactors, big enough to even fit a person? This is the large scale, because it needs to be shipped out in thousands of bottles. Do you think you just add more chemicals then do everything else the same? That's not how it works, because problems will occur if you do this. So chemical engineers focus mainly on chemical process design, like designing a processing plant, or a big one for them is designing chemical reactors, which is where the large-scale chemical reactions take place. And of course there's more equipment than what I've shown so far. But let's look at an example of manufacturing beer, which I said is something chemical engineers can do. Well, there are people out there that brew beer at their house. But this is the smaller scale. Chemists or chemistry majors could understand on a deeper level the chemical reactions that take place during this process and could look for ways to improve it. But if we look at a company like Budweiser, they have to produce large amounts of beer, so they don't have some home station. They have large reactors that make the beer, and this is where the chemical engineers come in. You can't just take that same at-home formula and make everything bigger. Lots more has to be taken into consideration. So to make that reactor, you have to size it properly. You need to design the cooling jacket, which is a layer of cooling water that surrounds the reactor to maintain the proper temperature, because you don't want it to get too hot. You need to design all the safety components such as the temperature sensors, the flow sensors, and the control systems that go along with them. If the temperature sensor says it's getting too hot or cold, the control system tells a valve that is letting in steam to open or close based on the temperature. This seems like something an electrical engineer might do, but chemical engineers will see this as well. You'd also have to design the pressure release valves to maintain proper pressure within the reactor. On a small scale, you can use a simple valve, but with a huge tank there needs to be a very specific pressure release valve. Also on a small scale, you can just pour in materials like the yeast to make the beer. But on a large scale, you have to design the piping that delivers the material, because if you deliver too much too fast, then problems can occur. And this is why you do have to understand chemistry, because you have to know what's going on in the reactor so you can apply the engineering principles to design it safely. How fast a reaction happens has to do with kinetics, which I'll talk about soon. But did you notice something about everything just listed? It's really not directly chemistry related. You have to understand the chemical process going on in the reactor that makes the beer, but there's so much more like the valves, controls, pipes, sizing, etc. that isn't directly chemistry related. And this is where chemical engineering and chemistry are different. A chemist would not be doing everything just listed, as that contains a lot of engineering rather than strictly science. So to be more specific, a chemist or chemistry major learns more about the reactions on a smaller scale, and they have a deeper understanding of those reactions. So if you want to be the person who puts on a lab coat and works solely with chemicals, chemical reactions, formulas, etc., then you'd probably want to major in chemistry or maybe even biochemistry if you want to look at the chemical processes within living organisms. But you would need to get a master's and even consider a PhD. Those are the people who are designing the new types of medicines, gels, detergents, and so on. But then they usually hand off that information to the chemical engineer, who then scales up that process. And they design the plant, the reactors, and so on, where that same chemical reaction will happen, which is why they still need to have an understanding of the chemical reactions. But much more needs to be accounted for. Now, I will say that this isn't always the case, so don't take it as a guarantee. There are chemical engineers who do work in a lab and work on chemical design like a chemist would. But usually they work on more of the large-scale plants and reactors, which involves so much more than just working with chemicals. Now I want to briefly go over their curriculum. Chemical engineers take all the same calculus classes as pretty much all other engineering disciplines, and they do apply it in their other classes. So yes, chemical engineering does have a good amount of math, even calculus level math, and it is more math intensive than the chemistry curriculum. So that's just something to keep in mind. Now they also take general chemistry, organic chemistry, and most will also take physical chemistry. Each of these take about a year to complete, but schools may differ. And note, these are all chemistry classes. They're not listed as chemical engineering classes. And this is the main similarity in terms of the curriculum between a chemistry major and a chemical engineer and even a biochemistry major. Those majors will take all of these courses. They aren't the only similarities, but a good amount. In general chemistry, you go more into depth about lots of chemistry concepts such as chemical equations, chemical formulas, atomic structure, etc. The beginning of this class would be similar to high school chemistry, then you learn more topics later on. In organic chemistry, you learn about carbon-containing compounds. This has a lot of applications in drugs and medicine, but in the class you'll learn functional groups, three-dimensional structures of these molecules, organic reactions, and so on. Then physical chemistry is where you learn about quantum physics and how it applies to chemistry. So you learn more about the physics of how atoms and molecules behave. This is probably the most math-intensive chemistry class that you would take. One important chemistry concept is kinetics that I talked about earlier, where you understand how fast a reaction will occur. Some universities have this as its own class. So if you have a hypothetical example of converting A and B into C, then this may be the starting concentration on the left. And after some amount of time, you have a different concentration, and in kinetics, the foundation is analyzing the speed at which that reaction occurs or how the molarity changes over time. So the rate at which this happens might be given by some curve of concentration over time, which is not linear as you can see. So for those who have taken calculus, you can see how you might need to use it. Like the derivative or slope at one point can tell you the rate of the reaction at any moment in time. And as you can guess, you'll also get into differential equations. And if you haven't taken calculus yet, don't even worry about this. Just see how kinetics is a very math-based topic, and I just wanted to give a very basic example of how calculus can apply to chemistry. In the real world, a chemist might analyze characteristics of a reaction, then the chemical engineer would take that data and figure out how to design a large-scale reactor where the reaction can occur. So if we think back to the manufacturing of beer on a large scale, I said you have to design the pipes that would add chemicals into the reactor. It all has to be controlled and the liquids need to be applied at the proper rate. If the reaction happens too fast, problems occur, including the reactor possibly blowing up. So hopefully you can see why chemistry is important for chemical engineers, even though they have to focus on many other things. So that was a list of a little bit of the chemistry that you learn, and a lot of these concepts are foundations for what you learn in your chemical engineering courses. But in those courses, although you need to apply some chemistry concepts, you really focus on more engineering topics as well. Like you'll take classes on thermodynamics, fluid mechanics, and heat flow, which a mechanical engineer would see as well. The classes have their similarities, but also their differences as they apply to different applications for each major. These are also very math intensive, where you learn the physics of how heat moves through materials and how fluids behave in different systems. So like when I talked about the cooling jacket for the chemical reactor, this goes on the outside to maintain the proper temperature, and that's where thermodynamics or heat flow would be important, and understanding how heat will move through the reactor. When it comes to designing the pipes to transport the fluids or chemicals, that's where fluid mechanics comes in. The pipes must be able to sustain the proper pressure and speeds the fluids will be moving at. And there are of course many other classes that you take in chemical engineering that I'm not going to go into. Now in the real world, chemical engineers could work on the computer and simulate or model the plant or reactor that they are designing. There is software that even models how liquids will spread throughout a solution as they are being poured in. They could walk around the plant to check on the sensor readings for various reactors to make sure that everything is safe within the area. They could work with other engineers to ensure they are producing enough, that everything is efficient enough, and so on. So as some final thoughts, if you're maybe in high school or early college and you're thinking that you loved your chemistry class more than anything, should I do chemistry or chemical engineering, or maybe biochemistry or something else? There really isn't a right answer, but I will say this. Of the chemical engineers who helped with this video and what I've seen online, a common thing that chemical engineers have said is something along the lines of, I like the idea of doing experiments using beakers and test tubes and the chemistry behind that. But what I really wanted to do was to take that and figure out how to make it on a large scale so that it can go out to consumers or businesses. They enjoyed the chemistry, but that was just one part. They also wanted to learn the engineering principles needed to mass produce whatever it is they were most interested in working on. So just to summarize, remember, if you want to strictly work in a lab and do experiments, then you might want to consider chemistry or even biochemistry. But definitely consider getting a master's or PhD if you want to do the high-level design work. With just a bachelor's, you'll most likely be a lab tech to begin, where you'll be following step-by-step instructions given you by a superior, and it won't be as academically challenging. If you like chemistry but want to figure out ways to produce materials safely and efficiently on a large scale that is also environmentally friendly, then chemical engineering will be right for you. Chemical engineers could work in labs like a chemist does, but it's just less common to find that. And also when it comes to chemical engineering, you really just need a bachelor's degree to be qualified for the majority of entry-level positions, which in the US have a median starting salary of $67,000 per year. It'll be very rare to hear of someone with just a bachelor's in chemistry or biochemistry getting that salary right out of school. Chemical engineering is again extremely broad, and there's a lot that you can go into, and you have to have knowledge of chemistry, but also physics, engineering, fluids, heat flow, controls, and so on. So hopefully you now have a better idea of what chemical engineering is and whether it's the right major for you. If you like this video, don't forget to like and subscribe, and I'll see you all next time.